Let's now examine one of the most important problems regarding the LEM: the absence of a visible flame under the engine during the departure from the Moon. The Luna module consisted of two separate blocks placed one above the other. Each block was equipped with an independent engine. The first one was used to land the entire spaceship on the lunar surface. The second was used for the liftoff of the upper part of the spaceship, the one carrying the astronauts. Both engines used a special kind of fuel called hypergolic. This is a fuel that burns on simple contact between two chemical components, with no need for an actual ignition system. The debunkers claim that the reason for the missing flame is due precisely to the use of hypergolic fuel. On his website, Bad Astronomy, debunker Phil Plait writes, "There is actually a simple reason why you cannot see the flame from the lander when it took off. The fuels they used produced no visible flame." In his book, Activissimo also writes, "The product of combustion from these fuels is colorless and transparent. This is why there is no flame under the LEM when it takes off." But these statements are false. Hypergolic fuels produce a clearly visible flame, both on Earth and in the vacuum of space. This is a test from the engine of the rocket SpaceX, which uses hypergolic fuel. As one can see, the flame is clearly visible during the combustion. And this is a test of the LEM's Ascent engine, exactly the one we are discussing now.
To keep it simple, it used so-called hypergolic propellants, a rocket fuel and an oxidizer that explode on contact.
The long flame from the hypergolic fuel is clearly visible under the LEM's engine during combustion. In the original images from the Apollo missions, however, there is no visible flame. This is Apollo 15, lifting off from the Moon. This is Apollo 16, and this is Apollo 17. In all cases, there is no visible flame under the engine during liftoff. Some might think that hypergolic fuel, which is clearly visible on Earth, for some reason may become invisible in the vacuum of space. But it is not so, and there are several examples to prove it. This is a Draco engine, which uses hypergolic fuel tested in a vacuum chamber. As one can see, the flame produced by the engine is clearly visible. The Space Shuttle also uses hypergolic fuel for its orientation rockets, and the emissions from the rockets are clearly visible during the maneuvers in the vacuum of space. This is another image from the shuttle maneuvering in space. The jet from the hypergolic fuel is clearly visible. This is a Soyuz spaceship, filmed as it approaches the International Space Station. The Soyuz also uses hypergolic fuels for its directional rockets, and also in this case, the jets are clearly visible despite being in the vacuum of space. In fact, they are even more visible because they are pitched against the blackness of space. All these examples show how hypergolic fuels are also clearly visible in the vacuum of space. We then ask the following question. Given that this is the LEM's Ascent engine tested on Earth, why is there no visible flame under it when it takes off from the Moon?